Welcome everyone. In this video we're going to cover problem number 8 in the chaotic review, finding the area between f of x and g of x on the interval from 1 to 3. So whenever we try to find the area between functions, we need to know what is the big function versus what is the small function, right? Which has bigger y values versus which has smaller y values. And so we're going to go ahead and maybe graph these things as my first step. So I'm going to go ahead and do a graph here. I'm going to do on the interval from 1 to 3, because that's the interval that's specified for us. And now let's go ahead and choose some points and plug them in and see which function's kind of on top, which one's on bottom. So let's say maybe f of x, if I plug in x equals 0. So 0, let me maybe make a table here. Actually, I don't even need 0 necessarily. Let's even start off with just 1. Right, so I'm going to start off with 1 here because, again, I'm on the interval from 1 to 3. So that's going to be my x value. Let's see what f spits out. So if I plug in 1 into my f function, let's see, I'm going to have 1 plus 2 minus 3. So that's going to be 0 altogether. So I'm going to have 0 here. If I plugged in 2, so 2 in for my function f, so 4 plus another 4 minus 3. So that's going to be 8 minus 3. That's going to be 5. So when I plug in 2, I get out 5. 1, 2, 3, 4, 5. So something like this. And then when I plug in 3, this is going to probably be even bigger yet, right? I'm going to get 9 plus 6 minus 3. So 9 plus 6 would be 15 minus 3. That's going to be 12. So way up here, can't even do it. I'm going to just mark 12 right here. This is not going to be a great graph. It's going to look something like this. Okay, how about the other function, right? So I'm going to go ahead and make another column here, and this is going to be g, right? So if I plug in 1 into my g function, right, I'm going to get 1 squared minus 1. That's going to also be 0. So, okay. How about if I plug in 2? If I plug in 2, I'm going to have 2 squared would be 4 minus 1. That would be 3. So 1, 2, 3, something like this. And then how about when I plug in x equals 3, I'm going to have 9 minus 1. That's going to be 8. So 5, 6, 7, I'll say this is 8. So to me, it looks like this green function, right, is always below this blue function, right? So g is smaller than f. This is not the best drawing, but this will work, you know, if it comes to an exam or something like this. We just need to know which one's on top versus which one's on bottom. It doesn't look like they make any switches, right? It seems to me that the green is always on the bottom. But let's go ahead and make sure that, right, secretly there isn't maybe an intersection over here. So if I was to set these things equal to each other, the x squared plus the 2x minus 3 equals x squared minus 1. And if I went ahead and I solve for this, right, maybe I cancel out the x squareds on both sides. Let's go ahead and add 3. So I'm going to have 2x is equal to 2. So this tells me that they only cross at 1. So right, this is the only opportunity really that they have to have, you know, one that maybe was on top go to bottom, or one that was on bottom go to top, or something like this. So this is the only opportunity that they have to cross. So in this case, we know then that f is always on top, g is always on bottom, and now I am confident, right? Because I was trying to figure out what should the order be here. So it should be f x squared plus 2x minus 3. Subtract away. So this is the big function. Subtract away the small function. So in this case, x squared minus 1. Integrating with respect to x here, my x's range between 1 and 3. So this is the hard bit, the setup. Now the evaluation's typically not so bad. So x squared minus x squared, that perfectly cancels out. And so we have 2x, and I have negative 3 minus a negative 1. So that's going to be negative 3 plus 1. So that's going to be negative 2 altogether. Now we go ahead and we integrate. I'm going to have x squared minus 2x. I need to evaluate that from 1 to 3. So when I plug in 3, let's see, I'm going to get 9 minus 6. When I plug in 1, I'm going to get 1 minus 2. And so let's see, I have 3 minus a negative 1. So that's going to be plus 1. So my final answer is 4. Now remember, it asked for area. Not net area, but area. So we know area should always be a positive number. So in this case, we got out the answer 4. I'm happy with that. That's a positive number. If I had gotten the answer negative 4, right? For instance, if I had switched these things, if I thought maybe that x squared minus 1 was bigger and then x squared plus 2x minus 3, and I had switched these things, I would have gotten out the answer -4. So this is an indication if you get a negative answer, right, that we've made some mistake, and now you need to go back and figure out, was it in your evaluation or was it in your setup, right? So in this case it would have been in my setup if I switched these two. So the answer is 4, that's positive, that seems reasonable to me, and that's the end of the problem. Thanks for watching, I'll see you guys out there.